Now that we answered the first question and learned about the law of large numbers and why we can replace the population mean mu with the sample mean x bar, let's take a look at the second question. What is happening with the standard deviation, and why can't I just replace the population standard deviation sigma with the sample standard deviation s? So I touched on that a little bit in the last video, and that's because s is not an unbiased estimator for sigma. So let's look at this a little more closely and why that's the case. So the standard deviation needs to be adjusted based on the sample size because averages have less variation or spread than individual values. Another way of saying this is that averages are more consistent than individual values. So it means averages are more tightly clustered together, and individual values are going to be more spread out. So instead of a standard deviation of sigma, we're going to use the standard deviation of sigma divided by the square root of n, or our sample size. So there is a proof and reasons behind why we're dividing that by the square root of n and why that's the right thing to do. That's kind of something more for an advanced class, although you are certainly welcome to reach out to me and we can kind of discuss more of the specifics of why that's the case. All right, so let's get a little bit of practice with this standard deviation. Juanita makes a measurement in a chemistry lab and records the result in her lab report. Suppose that if Juanita makes a measurement repeatedly, the standard deviation of her measurements will be sigma equal to 10 milligrams. Juanita repeats the measurement 4 times and records the mean or average x bar of her 4 measurements. So some questions for you to work on. What is the sample size n, and what is the standard deviation of Juanita's mean result? And there are 2 additional questions that will kind of help you work a little bit more with this standard deviation. So the first one is, if I know what standard deviation I want, how do I find that sample size? So in other words, how many times must Juanita repeat the measurement to reduce the standard deviation of x bar to 2? So there's a little hint there. I kind of filled in the formula where I left n as n and I made the standard deviation 2. So you could use a little algebra to solve for n, or you could do a little guess and check. And then explain to someone who knows no statistics the advantage of reporting the average of several measurements rather than the result of a single measurement. So go ahead and pause the video and give these a try. All right, let's take a look at this. So the sample size n, this one kind of trips people up sometimes because they spell the sample size out using letters rather than a numeral. So our sample size is going to be n equals 4. And then the standard deviation of Juanita's mean result based on those 4 measurements, we'll take 10 and divide by the square root of 4, our sample size. And so that gives us a standard deviation of 5. All right, the next question, instead of a standard deviation of 5, Juanita wants a standard deviation of 2. So how many times does she have to do these measurements to get that? So I filled in that formula for you as a hint, and to solve it algebraically, you could take that square root of n and multiply it up by the 2, and then you could take that 2 and divide it back under the 10. So you'll end up with 5 is equal to the square root of n, and if you square both sides, what that tells us is that Juanita is going to need a sample size of 25 measurements to get her desired standard deviation here. Right, and then explain to someone who knows no statistics the advantage of reporting the average of several measurements rather than the result of a single measurement. So what I did here in this graph is that I graphed this lowest line, this red one, that looks like a very just flat hill. That is a normal distribution, but it's based on a sample size of 1 and a standard deviation of 10, so it's very spread out. In her lab report, she used a sample size of 4, which is this middle curve. So it does have a little bit of a peak, and it's a little more tightly clustered, but it is still spread out quite a bit. Now, if we get that standard deviation of 2 that takes a sample size of 25, that's this green one, the one that is the tallest here. And so you can see that those values are going to be much more tightly clustered together. And so reporting that average of several measurements is going to give you a more quality answer here.